Hello, this is Beth Benzing. This lesson is on 12.2, section on transformations to achieve linearity. The first thing I need you to do is upload Fathom by using the disk or downloading it from the internet. And once you're uploaded, you need to enter the data in from the worksheet to achieve linearity by dragging a table down and labeling it year and then population. Go ahead then and enter in the years that are on the worksheet, and then we'll take a look at the data. Okay, the first thing we should do is look at the graph. So to create a graph, a scatter plot, you're going to select graph, drag it down to an empty space, and we're going to drag year to the x-axis and y to the or population to the y-axis. And if you right-click, you're going to go to least squares regression line. And if you look at it, it doesn't look that bad. And if you see, your r squared is high, and it gives you a regression line, so it's not bad. So that's the first thing. You should look at it, check your high r, so we're pretty happy so far. And the third step, as we learned, is to check the residual plot. So we're going to right-click to create residual plot. Again, you can do this on your graphing calculator. The residuals are already in there after you create your linear regression line. And in Fathom, we're going to go down to make residual plot. And let's take a look. Uh-oh, we see a pattern. We see this curve going from down low up to high. So at this point in time, we're going to question our linear regression line, our linear line that we created, and we need to do something with the data because now we're going to assume that it's nonlinear data. So the graph sort of looks like a curve. The dots, excuse me. So if it looks like a curve, it could be an exponential. If it was an exponential function sort of has a curve to it. Let's think about an equation of exponential. If we have y equals 2 to the x, the goal here is to make it go linear, because there's only one type of regression line, and that's a linear regression line. The TI calculator comes up with all these other kinds of regressions, but they're really no such thing. That's TI talk. There's only one type of regression equation, and that's a linear regression equation. So we need to transform the data to make it linear. To do that, we need to, we're going to try to get rid of this variable that's an exponent and make it become linear. So one option would be to log our y value, our x squared, our 2 to the x, excuse me. And if you log 2 to the x, the exponent can come out front. So it's going to turn into x times log 2. And x times log 2, with the coefficient being log 2 times the variable, will make this equation go linear. And let's think of another example of this. So if you have x squared, here, you could square root the y values, and if you square rooted them, then your new function would become linear if you square rooted your output. So that's what we're going to do. We're going to go back to Fathom, and we're going to try logging our output to see if it makes it go straight. If it did, then we can then assume that the original data was exponential to begin with, because the variable would come out front. Let's see what happens. Okay, so we're going to log population. Let's just call it log pop. And we're going to right click on that and edit the formula. And we're going to type in log parenthesis population. And I know it accepted it because it turned my commands in color. So one turned in blue and one turned in pink. So I know that it accepted those terms. And there's your log terms of the population. Now let's take a look at the data. We're going to put year on our x-axis, and we're going to put log population on the y-axis. And wow, it went pretty linear. It looks linear. What should we check? We should check the linear regression. Let's do these squares. And the least squares, wow, a regression R of 1. Now that's rounded. It's not perfect. It's probably like 0.99, but Fathom's rounding it pretty high, which is fine. And we should also check for the residual plot to see if it's any good. So we're going to check the residual plot, and it looks like it's pretty scattered. Now, It's only 5 points, so it's not going to be perfect. But picture a kindergartner just putting 5 random points up on the table. And that's what it would sort of look like. Bam, 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 bam. There's no like real set pattern to it. So this is going to be considered random. And so it's a pretty good fit. Now, here is our model, but we want to manipulate this a little better. And that's what we're going to work on right now. So Fathom came up with this is your linear regression on the data that was graphed as year with log population. And when you graphed the log population against the year, it turned out the dots looked pretty linear. Our residual plot showed no pattern, so we're pretty happy. And the equation of this line is this right here. Now, is my data really y equals this? No, it's actually log of the population equals 0.0184 times the year minus 33.346. Okay, so if you could type exactly, if you could actually log the population and transform it, then we're set. But the problem is our calculators, I want to be able to graph an equation against the original data set with population against year instead of log population. So we need to algebraically solve for population. So if you're logging the population, how can I isolate the population? Well, this is something you learned in functional or maybe in algebra 2, but what we're going to do, let me change colors here. We're going to raise both sides to the 10 power. And I'll show you your property in just a minute. But 10 raised to log of happy smiley face equals happy smiley face. So that's the property that you learned once in your lifetime. And so that's what's going to happen. So we raise both to the 10 power. By the way, if you're ln'ing, natural logging, you would raise it to the e power. And there's a few questions in your homework that ln it, so you want to raise it to the e. So we're going to raise it to the 10, and 10 log of population, or 10 raised to the happy smiley face, is that value. So yay, we isolated population, and that's going to equal 10 raised to this particular function. Okay, so we are now going to, since we transformed the function, we're going to graph it against our original data to take a look at our transformed new equation. So we're going to create a graph, drag a graph down, and plot year against population, or population against year, please. And now we're going to right-click and go to plot function. And it already gives you population equals, so we're going to type in 10. And then raised to, we're going to do that caret, and then you're going to see Fathom's going to put it up there. And we're going to type in the function that we see. So type it in, and then push enter. And wow, it looks great. Looks super. So, so this is your model right here. And how did we obtain this model? We obtained this model by transforming the data, created a linear regression line on the transformed data, and then as you remember, here's our model right here in black ink right here, and then we just algebraically solve for population. But this black model right here, this black equation right here, is the correct model, but we just wanted to make it look a little nicer and set it equal to population. So right here is our model, and we'd be able to estimate where we would be by plugging in a certain year into the equation, or vice versa by plugging in population and solving for year. So to end this video, I did want to share, I used to do this in the TI calculators, this exact same lesson. And then what we would do is we would go to TI and we would actually calculate the exponential regression that's in their calculator that I'm sure some of you have seen before. And you're going to see the model comes up to be exact same model as the one that you just created by your transformation line. So the exponential model is doing the exact same thing. The TI people just did the transformation for you and called it an exponential regression. Remember, an exponential regression does not exist. What they're doing is they're transforming the data, creating a linear regression line with the transformed data, and then transforming it back to come up with a nice model. So thank you, and we'll do the next problem on the next video.